Okay, so I've started the recording and it's just now 12 o'clock. So thanks for joining. And let's see, I'm going to get this on full screen here. All right. Okay, so we just finished chapter 15 on climate change, and I'm going to go over a few things of that, and then a little bit about test 4 and test 5 and what's coming up. I'll do that, I think, a little bit at the end because you might have some questions on that. And I first wanted to go over a little bit on your assignment on climate change. There were a couple of things that people commonly made mistakes out of, but they were hard for me to correct. And so I just wanted to make sure that first of all, on your, right here where you did that first chart, that on the first one of climate change, it's got these particular gases, and there were 5 gases, and most people got that. Nitric oxides are like 300 times more powerful. Methane is 100 times more powerful. And CFCs and other fluorocarbons and bromocarbons are up to 10,000 times more powerful as greenhouse gases. And they come from mostly from industry and refrigerants, and some from pesticides, even from agriculture and from electricity generation. So those are some of the sources of those. Another thing that people tended to get wrong is it asked a little bit below here, like right down here, it asked what the concentrate or what the average global temperature was in 1800, and I got a lot of strange answers for that, but the average global temperature was about 56 degrees Fahrenheit, and last year it was about 58 degrees Fahrenheit. So it's about 2 degrees difference already in the global temperature change, and that's a global average. And of course, that global average doesn't really or shouldn't really vary any at all if we want to stay in the same temperature. But of course, that's changed over time, and we are in a time of rapid change. I want to share some of the slides with you. So I'm going to go to the PowerPoint and go to a couple of things that I want to point out to make sure that you understand. And they will be on the test, of course. Energy, of course, is the basis, and chapter 13 is also on test 4. But energy is the basis of everything. And from E equals mc squared, that is who we are and who everything on Earth and in the universe is about energy. And so it is the basis of existence. It is the basis of what mass is made from energy. And fossil fuels are concentrated energy. So the sun, our energy basically is coming from the sun to keep any additional energy that we need to do everything comes from the sun. And for millions of years, it's been going into plants. For billions of years, it's been going into plants. But then a lot of those plants died, many, long eons ago. And the death of those plants accumulated and fossilized. And that's what fossil fuels are. So basically, it's concentrated solar energy deep inside of plants underneath the earth. And when you take those fossil fuels out of the ground and burn them, this is the calculation. So this is a calculation a lot of people continue to miss, is that you've got hydrocarbons. So plants are mostly carbohydrate, but after millions of years of decay, that carbohydrate changes into hydrocarbon, and the oxygen leaves. So when you have that hydrocarbon, you bring it up out of the ground, you burn it by adding oxygen. You know that when you light a fire, it needs to have air in order for it to burn. It's the oxygen it's getting. So with the carbon, the hydrocarbon plus the oxygen, if you burn them, the outcome is lots of energy. And it also gives off CO2 and H2O. And you can remember this by blowing on your hand. And your body, all the metabolism in your body is actually using up food. And that food is carbohydrates and proteins that are made of carbon and hydrogen. You add oxygen by breathing. You burn that food in the metabolism of your body, and you're putting out CO2, water. You can feel the dampness and the energy. You can feel the heat that comes out. So that's true of just about most energy on Earth comes from that process. And so that equation is an important one to understand, that we need oxygen to get that energy on many, many different levels. And of course, in your PowerPoint slide, it used that our whole life. So, just in the past few hundred years, we found this creative energy deep inside the earth. We can pull it up and we can burn it like crazy and use it for all kinds of things. And that's what we've been doing, having way too much fun uh, without even recognizing the consequence, the damage to the ecosystem that we have done in using this energy. So we use energy to build factories, and the factories put out pollution. To build the factories, we have to have metals that have to be mined. We have to have trucks, and we have to have ships, and we have to have all kinds of things, machines for agriculture, stores, and blacktop, and planes, and basically everything we do uses a lot of energy and a lot of habitat to do that. And we look at a picture like this and it looks beautiful, and we say, oh, that just looks all natural, doesn't it? But actually, this is a picture in Virginia, and this should be all forest by nature. So if it was a natural habitat, it would be total forest. But we changed it into agriculture for human use. That might be okay over a small area. It would be fine if there was only a billion people. But with 7.8 billion people, we're changing the entire earth. And of course, that gives us lots of waste. And so climate change is just one of the things that's happening. It's a combination of just using too many resources on the earth, destroying our habitats while we're doing so. And our atmosphere is very thin. We can see it from space. We can see our planet from space. There's only one Earth that we can survive on, and we have to recognize that how much damage we've done. And can we survive is of course a huge question. Okay, I'm going to go down to a few of these other sides. Slide number 29 here. And this one shows basically things are happening. So climate change has been happening for some time, since the 1800s, but it's escalating. And in the past 10 years or so, we've seen these escalations happening with more and more drought and fires out west, more and more floods and hurricanes in the east, and more migrations because, people just can't live in some of these places. And so we are all human. It's going to come to our house one day, maybe, maybe not. If we're really lucky. But basically, people around the earth are on the move because of climate change, and that's causing lots of problems. And of course, when people on the move, they're going to use even more resources. If your house is burned down, you need another one, and so it's a feedback effect. And speaking of feedback effects, I'm going to go to that slide. This is a very important topic, and I think most of you got it on your worksheet that you worked on. There's positive feedback and negative feedback. And it doesn't mean good and bad. Positive means it increases. And it increases whatever the effect is. Nature is mostly about negative feedback. Negative feedback keeps things in balance. So when something gets too much, something else happens to bring that down, to keep life in balance. When our body gets too hot, we sweat, and that sweat evaporates and cools our body. When our body gets too cold, we shiver, and that shivering causes a lot of metabolic reactions to give off heat and warms our body. And so those are negative feedbacks that our bodies do to keep in balance. But positive feedbacks are when something increases. Another thing. And a positive feedback in nature, in humans, is when a mother is giving birth, her cervix begins to open, and that causes a chemical reaction that increases that. And so that's a positive. You want that baby to come out, so you have to increase the opening of the cervix. That's a positive feedback. But most of the time, nature is about negative feedbacks. But now we've got a lot of positive feedbacks going on in nature. And this is slide number 35 with lots of examples of feedbacks. The next one, so it's got melting glaciers. And so what happens when like for melting permafrost releases methane. So if melting permafrost releases methane, that methane warms the climate, which causes more permafrost to melt, which causes more methane release, which causes more, you get a constant feedback effect that increases that warming. And this is what's happening toward faster and faster warming. So we've got permafrost releasing methane. We've got the oceans, the ice. So the ice would be on the ocean. It should reflect the sun, and it usually does reflect the sun. But as soon as the ice melts, then you've got darker ocean, and that warms things even faster, which melts even more glaciers, which causes even more reflection to be lost when those glaciers are gone. So you end up with a lot more warming, a lot faster and faster. So these things are increasing as we speak, essentially, and are changing our climate. And let's see, and so this is an example of all kinds of things that are being changed around the world as our temperatures are changing due to basically, it's not just about excess CO2. Remember, it's about cutting down our forest and destroying our oceans, both of which should be absorbing a lot of that CO2, but they're not. And so, because we're cutting them down. So those are important. So let's go to, let's see, slide 36, 38, and 35. Okay, so those were about how methane works as a feedback effect. This is explains it kind of here, and you have got a lot of information on that, and I think you did okay in your handouts. So the last thing I wanted to go, so lots of things are happening. There's, this was paradise. I just thought that is so sad and so ironic that, these people think they're building a paradise, and then all of a sudden, climate change causes so much drought in their area that they can't stop the fires. That makes everything turn to tinder. So the higher the temperature, the drier the leaves, the more easy they burn. And so that's a problem and causing feedback effects in those areas. There's a lot of things out there about what we should do. And of course, our economy says, go out and buy more stuff, and that's what's killing us. And so economic growth, basically, the more stuff people buy, the more consumerism there is, the more we tear down our forest and release and use our fossil fuels to release our methane. So economic growth is actually driving a lot, in fact, most of climate change. So what can we do? So this is one of my favorite cartoons. Basically, we've got these big brains and we just haven't dealt with them properly. So we can talk about ADHD, and I think it's a problem of humanity in general, that we have, we might think we're really smart, but unless we focus our concentration on doing the positive instead of the negative, we have gotten ourselves into really big trouble by using our brains to poor effect instead of to good effect. So what can we do? First of all, we've got to understand the problems and see what we can do by ourselves and in our communities. So basically, we're here during amazing times. So if you understand anything that's out there, we must have some purpose in these times today. And so getting motivated about what we can do, and some of the things that we can do is basically putting nature first. And I think this is one thing that COVID has done for us. It's put us in our own home, and most people are enjoying nature a whole lot more. The people are gardening more. The seeds are running out. So if you want to garden next spring, you better go ahead and buy your seeds. But living simply, we know that these kinds of things are better for the heart and the spirit, to live in simply and in harmony with nature. So no matter what happens out there, being able to adapt to it, to understand that nature is so much an important part of us, to be able to go out in nature, to soothe our spirits and to feed our bodies is important. But also changing the rules. So it's a voting day. I hope you've all voted for a better handle on nature. I hope you voted for people who will support our environment over just consumption. So it's really important for us to survive. So taking pleasure in local nature and each other is something that we can all do. Okay, so I think I'm going to stop with that. And then are there any questions about climate change? No? Okie doke, then I will go a little bit about what's happening with chapter 4. So chapter 4 is coming up next Tuesday. As you know, it'll be available after 2 o'clock, same as the other ones. We'll meet, we'll have a Zoom in the morning if you want to ask more questions right before we start the chapter, before we start the test as usual. And that will be over chapters 13 through 17, but not 16. So 13, 14, 15, and 17. And then chapter 5 is the final, or test 5 is the final exam, and it counts the same as every other test. And as I told you in the beginning, one test is dropped, and that can be any of the tests. So people who had emergencies might have already gotten a 0 on a test or something like that. But your lowest test grade has been dropped, but that will change if you get another low test grade. And so it'll be your lowest test grade, whatever out of the 5 of those tests that you take. So what I will do is, because one test grade is dropped and lots of people would just not want to take the final exam, after test 4 and you've got all your grades for all 4 tests, I will give you a 0 on your final exam temporarily. And you will be able to see, well, what will happen if I just don't take the final exam? And that will be your grade. And you can stop there if you want. Or you can replace that 0 by taking the final exam. And hopefully, if you do better on the final exam than you did on your other lower test, it will bring up your grade. But you have to do better on the final exam than on any of your other test grades. And of course, if you got a 0 on one, of course, anything is better than that. So taking the final will be good for that. Are there questions about taking the final? Okay, I'll go over that again after we taste our next time, and then I'll put another little note out about it. So hopefully it's clear to you. Well, any other questions before we go? Okay, beautiful out there. Get outside, enjoy nature, and I will see you next week. Bye-bye.